Alright, this would not be my preferred way to do this, but I'm having some technical difficulties, so here we go, improvising. Alright, I said section 6 in class, but it's actually 4.7, alright? So isometries and glide reflections. And so the definition of an isometry, just a fancy word, iso, we've seen iso before, that little prefix, okay? It's like isosceles, so things that are equal or things that stay the same. So a transformation, any of our things that move points around, okay? Transformation is an isometry if and only it is a reflection or composite of reflections. So basically, if it keeps things congruent, it's an isometry. All right, so sometimes these are called congruence transformations, isometries, okay, that keep things congruent. And then the last one we have here is a glide reflection, okay? So glide, different from a slide, but it's a combination of a slide and a reflection. So it's a composite of a reflection and a translation. And remember, translation requires 2 reflections. So this is really a composite of 3 reflections. And so you can kind of think about what that would do to the orientation, right? So that's going to be another important thing here. And we're going to talk about vectors later on, but it's parallel to the line of reflection, and that's kind of part of what our vector situation is about, okay, the direction that it's going to go. And then because it's parallel, right, we also know something about that whole twice the distance between the lines. Twice the distance between the lines, all right? So I think I did this in class with some of you, all right? So this is a reflection. You just reflect over. And then if you reflect and reflect, you slide, right? That's a slide. And then a rotation would be like you lock your elbows together, okay? And then rotate. So orientation here is the same. Thumbs are still kind of off to the top or left of your hand, okay? And then a glide would be this. You reflect and slide. Okay, so you slide apart and reflect. And then that leads us to sort of a little summary, okay, of all of our reflections. And so the isometry hierarchy tree, so again, putting things in some sort of graph or some sort of tree here to give us a diagram of what it would look like. So transformation is at the top. And that's anything that moves points around. And then underneath that would be an isometry, which is a congruence transformation, so it's one step more specific. And then under there we have some categories, right? I'm going to divide them up like evens and odds. Okay, so one reflection is just called a reflection. So it's just one reflection. And then 3 reflections, which we just learned here, is a glide reflection. And I do like you to kind of put both of those words together. It just kind of helps you remember that it's a reflection plus something else, a slide plus a reflection. And then in the middle here we have our two reflections, and that's when we have a translation or a slide. And rotation is the other one. Okay, so 2 reflections. This is 1 reflection. And this is 3 reflections. 1, 2, 3. So which ones keep the orientation the same? And it would be the ones in the middle here, the even ones, okay? So the orientation is the same because we flip it and flip it back. single reflection is going to make the orientation switch, as will a glide reflection. It's going to reflect, and then when you do the slide, it's going to switch and switch back, right? So that one is also going to be a switch in the orientation. Okay? So transformation is our big overarching category. And then the one that we've studied that's not an isometry is dilation. Right? It moves points around. It's a size change. It dilates. Okay? But it does not keep things congruent, where isometries are congruence transformation. So anything involving reflection, if you just do multiple reflections over and over again, that's going to always keep things congruent. Right? And that's a big, huge difference between dilation and isometries. And then as it turns out, anything beyond a glide is really just a repeat of one of these. So you never need more than 3 reflections. All right, if you get into 4 reflections, you could accomplish the same thing in less. All right, and so that's kind of a neat thing about this, is it's not just an infinite number of reflections out there. You can narrow it down and know that these are the only ones that there are. All right, so anything beyond 3 is just a repeat of something else. Okay. All right, so remember, very important, same size and shape. All right, which dilation here is similar figures, not congruent figures. All right, you do not have to do a whole dilation. You won't have to do all of those reflections. You will have to find the reflection line. And what we mean by that is the line that actually switches the orientation. All right. The slide, remember, takes 2 parallel lines. So it's, those 2 are not the ones we're going to worry about. We're going to only worry about the line that flips it over and changes the orientation. All right. So here's our original DEF right here. And so to find the reflection line, you're going to connect corresponding points, and don't pick ones that are where the lines are too close together, and don't pick ones maybe if the points are super close together. You want to have a little bit of distance here so you can get an accurate line. So use your straight edge and connect F to F prime like I have right there, and then D to D prime. And then you're going to measure and find the midpoints. Here that I marked. So on mine, I measured and found the midpoint of that blue line, and then measured and found the midpoint of the red. All right, so if you need to pause for a second and do that, go ahead. All right, and then take and draw that line. So that line here through those midpoints. Okay, so then you take your straight edge and connect the dots through those 2 midpoints. And that's the line that it reflects over. Okay, and I'll try to show you. That's as much as you'll have to be able to do on the test, okay? But I want you to kind of see the continuation of it. So if you go ahead, better if these were like triple primes or something up here, but just remember that's kind of our final end. We actually have to do 3 reflections to get to that point. All right, so if you take this now and fold, once you have the line, so again, if you haven't done this yet, pause and get that line on your paper. And then you're gonna fold over that line, and that will give you, okay, so we'll take that line and fold it over. There. And so here's my F. Okay, so I folded that over. And now you notice it doesn't line up with that guy perfectly because there's still a slide to do to get it there. All right, and then if we had two more lines, we'd need two parallel lines. And we would flip and flip, and that would get it to slide up there into position. Alright, so our reflection line just gets it facing the right direction. It changes the orientation and lines it up, so that now we could actually slide. Alright, so now we can just slide into position like that. So once we're here, just make sure it slides and lines up. Alright, so it's a reflection, and that line that switches the orientation is the line of reflection, in this case what we mean for a glide. And then the last thing on here is where orientation, kind of checking orientation, is really going to help you, because sometimes glides and rotations can look the same depending on the picture. It's hard to tell whether they've flipped or not. Alright, so this one, does this have to rotate? Could I reflect it? Could I just push it on top of each other? And so in this case, hopefully you can see that you could just push this K on top of that one, and you will just slide it. Alright, so it's like this. You just do a little slide, okay? And the orientation idea is that it's facing the same direction, okay? So for instance, if I started down here at the bottom of this K, and I went up and around to the little leg, I'd be going clockwise. And over here I do the same thing. If I start at the bottom and I go all the way around to that other little leg, I went the same direction going around. Okay, what about the F? Are they facing the same direction or not? Alright, so again, start at the bottom, go up the stem, and then around the little pokey things. That's a technical math term right there. Do the same thing on here, go up the F and around the little forky, pokey things, and we're going the same direction. So if the orientation stays the same, then it had to be two reflections. Alright, so the orientation for both of these, the orientation is the same. So the only question is which one is the rotation and which one is the slide. Alright, this was a slide, we push it. This one we would take the F and we rotated it around some point back here. Alright, there would be kind of our intersecting line, so we rotated it around that intersection. Okay, these two, the orientation is switched. So if you look at it, in this case, if I start at the bottom of the end, ends are a little hard to tell because it looks so similar to two forks, but if I go right up and around the first pokey part, right, so here I will start here, I go toward that pokey part, and then the bottom. Now I've gone the opposite way, and this one should be fairly easy to see that this is a reflection. Like there's your reflection line, right, and it's just dumped over. So this one is a switch in orientation. So the question is it one straight reflection? Could I fold and fold that right on top of itself? Okay, and I can, so that makes it just a reflection. Whereas this guy, it might feel like a rotation at first, okay, like he's just rotated, but again, check the orientation. Start at the bottom, go around the curvy part, right, and we'll call that clockwise. And then if I go here, up and around the curvy part, so I'm kind of following the same pattern I did. They're switched. This one's clockwise, and this one's counterclockwise. And so this one has to be flipped to get it facing the right direction. Take the P and flip it over, and then slide it into position. So this is the glide reflection. Alright, and it's really amazing that some people's S's and G's somehow magically look awfully a lot like you make an S, it sort of looks like a G, alright? So capital letters helps, or like I said, put both words, glide, reflection, so I know that you're not mixing it up with a slide. Alright, so orientation can help you kind of decipher those sometimes if it's hard to tell between that glide and a rotation. Okay, we'll do some practice of that next time I see you.